Good morning, dear students. Welcome to Vista's e-learning and online educational platform. My name is Denzil, your physics tutor for class 11. So let's get started with today's session. Today we start with a brand new chapter, a chapter that is called measurement. So this session will just be an introduction, a bridge course related where we connect your high school to your college level. So let's get started, session 1 of the chapter measurement. So what exactly is meant by measurement and why is it useful to us? Now let's take the case of a weighing machine. Every morning you wake up, you go and weigh yourself. Well, if you're too heavy, then you'd go under a weight loss program and then you check your weight and you'd make an accomplishment saying that you've lost weight. Alright, so let's take the other case, a ruler. Now, especially when you have to build, when a carpenter has to construct a table, he or she uses a ruler in order to measure the table. Quite simple. And one of the most important aspects of our lives is keeping track of time. Time is the most valuable quantity to us. You must have heard your parents already saying the time that is lost cannot be gained back. And especially when it comes to studying for your exams, you lose time, then you lose marks in the exam. So what do we see in all these three examples? In the case of a weight loss program, for a carpenter that uses a scale, and for us where time is valuable, what do we see? Is that we make measurements. So measurements is made every day, every single aspect of our life, there's measurement way. From the time that you wear your clothes, the clothing that you wear is also measured, which fits you well. If a clothing is not measured properly, then you would see that one of the sleeves will be longer than the other. That would look quite hideous, where one sleeve is longer, the other sleeve is shorter, or one trouser is longer, the other trouser is shorter. Hideous, right? So we would have a funny nature then. Now, if we want to be more civilized, act civilized, and also look towards the future, then we have to do what is called a measurement. So, what exactly is a measurement? Measurement is used to quantify an object. So, any object that needs to be quantified, an example, especially when you weigh yourself, that weighing machine has to quantify the object into a certain amount. So let's see exactly why measurement is necessary. So why is it necessary to make measurements? Now this is what happens if the measurements are not made for a given table. When you call someone on the other end of the phone, which is a carpenter, you tell the carpenter that the dimensions of so and so table, I want a table of so and so height. But the carpenter does not really know the measurements. So your preferred table would be so, but what you get in return would be something like this. Height of a table that is different because a measurement is not made proper. Also in the case of making a stairs, if a stairs have to be done right, then you need to make certain measurements for that stairs. If measurements are not conducted for the stairs, it would look something like this. This looks like an episode where a person is drunk and is trying to climb the stairs. Very hard, don't you think so? Yes. So life without measurement is very difficult. So it is very important for us to make measurement. So if we're making a measurement, how does one compare the different physical quantities? So what are the physical quantities? The different physical quantities that can be quantified, meaning that can be divided into certain amounts. So let's take a look at one example here, which is apples. Let's say these apples put together weighs 1 kg. So what just happened here? Certain number of apples, when put together, they form 1 kg. Now, don't worry about this particular kg, kilogram, but I want you to now look at the quantity. How we have taken the weight and put them in a number form to show that it has a certain amount, that it values to a certain amount, which is 1. Let's take the case of another, a distance. Distance moving, if you're moving from one destination to another, then you cover a certain path. Now, to cover a certain path, now this looks like a long, very long trip, a long highway. So let's say the distance from here to the other end is about 20 kilometers. Let's not worry about the term, but I want you to look at the number. 20, a given measurement of distance, that it is 20 times away from a normal, which can be quantified as 1 kilometer, 2 kilometer, 3 kilometer, and so on to 20 kilometers. So you take a given unit, a physical unit, okay, a physical quantity, and then you try to quantify it, meaning you break down into certain values. Similarly, an example which is time. Time, it is again, we do not have like a time, a clock or a watch that is given to us from above. It is not made as evolution takes place. I mean, it is made by humans, but the evolution takes it, but it is not just like the evolution, time does not evolve. Rather, we've placed time as one standard unit where we have quantified the time as seconds, minutes, and hours. Taking the third example, the case of a temperature, which is also measurement of heat that is around us. Okay, you're trying to measure the heat around you. This thermometer, which identifies the temperature, is again quantified. And how do you know if it is quantified? Look at the numbers that are placed on the thermometer. So these physical quantities, such as the mass, the distance, time, which is from the previous, and temperature, is what makes up the fundamental quantity, the most basic quantity, basic physical quantity. So fundamental quantities like mass, length, time, temperature. There are few more like current, and you have molar, and you have radians. So you have few other basic fundamental quantities, but most of all, remember these 4 fundamental quantities. So let us look into another example of this rocket ship which is zooming into space. This rocket ship which is moving, in order to identify how fast it is moving, you use one of a physical quantity which is called speed. Now, how we define speed is speed equals to distance by time. So I hope you remember this, because you have learned them in your primary as well as your high school, where you define speed as distance by time. Distance, as we know, is a fundamental quantity where length is involved. Time is a fundamental quantity where you have seconds, minutes, and hours. So when two fundamental quantities are put together, they give you another physical quantity which is called a derived quantity. So the distinction between the two, a fundamental quantity being the most basic quantity, and a derived quantity where 2 or more fundamental quantities are put together under a certain operation. The operation that we are conducting here is nothing related to the doctor's operation. It is more of a division, a mathematics operation. All right. So derived quantity are those when fundamental quantities are put together under a certain mathematical operation. and fundamental quantity are the most basic quantity. So here's another example of a fundamental quantity is a current. So this is an example where to show you, I want to show you it's a current as the fundamental quantity, okay, and derived quantity being the speed. So two distinct derived quantity and a fundamental quantity. Now that we have learned that there are various physical quantities, so how does this physical quantity with the respective units differ from one place to another? Let's take the case of standard system of units. The three standard system of measurements are usually FPS. So let me rewrite that. Okay. FPS. Then you have CGS and MKS. So these are the three standard system of measurement. So let me explain to you again what is meant by three standard system of measurement. Measurements that can vary from one nation to another. Especially when you move to a different continent, let's say Europe, there the measurement is little different. When it comes to weighing, their measurements are usually done using grams and pounds. And that is where FPS, which is also called a British unit of measurement, stands for foot as a measurement of length. So let me put that above as measurement of length. Then measurement for mass and measurement for time. All right. F stands for foot, P stands for pound, and S stands for second. So which means if you move to England, you will see that the measurement for length is conducted using foot. Measurement of mass is by pounds and measurement of time is by seconds. Now, if you go to another European nation, which is to France, you will see there they use which is called a CGS system. CGS, which stands for centimeter, where C stands for centimeter, G stands for grams, and S seconds. So here we observe that the measurement is changing from one nation to another. One is measuring in terms of FPS, which is foot, pound, second. The other is measuring in terms of centimeter, grams, and second. So if it is varying, then we cannot conduct a standard measurement. So in that manner, what happens? Scientific community would be a chaos. Because since there is no one standard measurement, we cannot make one proof. We cannot come up with one solid proof for a given system. So what we do here is introduce a standard measurement for all the scientific community. This standard measurement for all scientific communities is what is MKS unit. M, which stands for meter, K, which stands for kilogram, and S, seconds. So this is widely used in all the scientific community, in every single meter, kilograms, seconds. So therefore, especially when you're studying science or when you're dealing with some problems, an application-based problem in mathematics, it is always necessary and important to make note of these units in terms of meter, kilogram, seconds. Now that I have mentioned to you about a unit, so what exactly is a SI unit. So don't worry about this, we'll get to that. So what is a unit? When I give you an example of 1 kg of an apple, okay, 1 kg of an apple and 1 meter of a distance, which is nothing but mass, you're trying to measure mass, 1 kg of apple and 1 meter of distance. But if I go to the shop, the vendor, and ask him that I want just 1 apple. Now I don't specify the quantity, I don't specify what the unit is, I just specify the quantity, which is 1, but I don't specify the unit. So I just say I want 1 apple. So what the vendor does is he gives me 1 apple. But that's not what you wanted. You wanted 1 kg of an apple. So this is to show you how a unit, to denote a physical quantity, is very important. Kg is to denote which is mass. Meter, which is used to denote which is length. So these units are very important when it comes to differentiate, to compare one physical quantity with another physical quantity. So value itself does not have meaning. A value along with the unit, a value with the unit, so value with the unit defines one physical quantity. So when it comes to SI unit, it means setting a standard unit for a given physical quantity. Like in the previous case, we discussed that MKS is a standard unit. Now you may ask, who introduced this standard unit? Well, it is a community by what is called as a system international, the unit, as an international system of units. So here a community, they get together, which is actually in France. This is a French word which translated to international system of units. So here a community get together, scientific community people, they get together and set a standard unit for a given physical quantity. So now we know for mass, the standard physical quantity, or the SI unit. The SI unit is kilogram. For length, it is, the SI unit is meters. And for time, the SI unit is seconds. And similarly, we can also discuss what is the SI unit of temperature. For temperature, it is Kelvin, given by capital letter K. Kelvin, K. You can go on making note of other fundamental and the derived quantity SI units, because in case of force, the SI unit of force is Newton. I think you might have learned this in your high school as well. Yes. Force, newtons, given by capital letter N. So these are some examples of how an SI unit are written. Some of them are fundamental quantity or the base quantities, and the others which one example of a derived quantity, where force is nothing but product of mass and acceleration. Acceleration again itself is a derived quantity. So now let's get to the most important part of our class, is to how to convert one unit to other. So what exactly does it mean converting one unit to other? When it comes to measurement of length, now that we have seen that there are 3 different ways to measure a length, one where you can measure it in terms of foot, the other which it can be measured in terms of centimeter, and then the other which is measured in terms of a meter. So let's say if I have to convert the meter into centimeter, how do I do that? Now here's what you do. Here's a ruler towards my left hand side, your right hand side. So this ruler, it has a measurement only up to 30 centimeters, 0 to 30. But let's say that there is 100, okay, so it keeps going on until 100 centimeter. So this 0 to 100 centimeter ruler is what makes up 1 meter. So 1 meter consists of 100 centimeter. And why we call it centimeter? Century, 100, centi, 100, so 100th of a meter. So why is 1 meter divided in 100 centimeter? It means that you take a scale which is of a certain length and you divide it into 100 parts. So you take a scale which is of a meter length, all right, and you divide it into 100 parts. Each part will represent 1 centimeter. And like that, you have 100 such parts. Therefore, 100 centimeter is what makes up 1 meter. Now, here's another question for you. Try to answer this. If 1 meter equals to 100 centimeter, then 1 centimeter equals to how much of a meter? Go ahead, try to solve this and answer this question as to how much, if 1 meter equals to 100 centimeter, then 1 centimeter equals to how much of a meter? Okay. So, do I leave this as your homework? Yes, this would be your homework. So, try to solve this problem. It's a very easy one. 1 centimeter is how much of a meter? So, give me how much would be that value. Similarly, if I take a meter scale and cut it into 1000 parts, not 100 but 1000 parts. If I take a meter scale and cut it into 1000 parts, then one part of that meter scale will be 1 millimeter. Now the reason why we call millimeter millennium, millennia, which is 1000. So that is why 1000th of a millimeter equals to 1 meter. 1000 of a millimeter equals to 1 meter. So it just means you have a meter scale and you have cut it into 1000 parts. Each part will be 1 millimeter. So one part will be 1 millimeter, so you have 1000 such parts. So again, if 1000 millimeter equals to 1 meter, then 1 millimeter equals to how much of a meter? Try to answer this question by yourself. I will reveal the solution in the next class. So this is one of the unit conversions. There are few more unit conversions and we will have a look at it in the next session. In the next session, we will start with bridge courses for mathematics. We start with the arithmetic, some of the arithmetic as well as the algebraic equations. We will have a course where I bring in the concept, the missing concepts from your high school to your college. So I fill in those blanks, I fill in those gaps so that it'll be easy for you to learn further, which is for 11th and 12th standard. Okay. So if you've enjoyed this video, make sure you give a thumbs up, subscribe and click on those bell notification. Do visit us at www.p-learning to get more details about the classes. So I'll see you all in the next session. Until then, everyone, have a nice day, take care and see you all. Bye-bye.